Okay, now we all must be very bored with the same data, so let's import another one. I got this data from Kaggle. Do you know what is Kaggle? So Kaggle is a company which crowdsources a lot of data science competitions. A lot of companies put out their data and they host competitions. If you want to participate, become very, very good in Python, become very good in data science, please participate. Some of the grand prizes are up to $1 million US. So I picked up this data set, which is a real data set of Hollywood movies. I like this data, so I picked this up. Import pandas. Oh, I've already imported pandas. So I'm going to pick up the file name is movie. Just a second. Movie data dot CSV index for I think was index movies dot head. Okay, file not found. I think it was data set. Okay, so we have, what do we have these five rows for? Let's make it smaller. You're not able to see all this. My God, it's okay. So we have these are the various columns here, and we have a data set of Hollywood movies. Here we have only taken the top two, but if you look at the full dimensions of this, we will see movies is equal to, we have 4,800 records, 4,809 records, and we have 1,264 columns. That's really a huge data set of Hollywood. So let's try to make it a little meaningful for us and find some kind of things. We would want to know. So what kind of a problem that we can select? Any suggestions? Okay, fine. Let's find blockbusters. That's fair.
Yeah.
Yes.
Let's find blockbusters. Let's see what are the columns here. Okay, just a sec. Movies dot columns. We won't be able to see each and every column. Okay, we'd be interested in budget, genres, maybe original title. Obviously, we want to know the name of the company. Production companies. There should also be revenue somewhere. Let's see how much of sales they did. Let's see. Do we have?
I think popularity, under popularity, there was revenue.
Revenue
Yeah, or probably the number of people watching.
for columns. True. Okay, so fine. We do have revenue. So let's drop. We last time we did cover how to drop a column, but let's try Let's try it again. I'm not going to do on the original data. So we will make a copy of that data. And I will say the data dot drop. I will say, okay, let's drop homepage column. I'm not interested in that. I'm not interested in the ID either. Along column axis. Is clear? Okay. See, we don't see the home page and ID, which were the 0, 1, second and third column. So that's how you can drop column names. Okay. What if I were to drop by a row number? And remember, if row names are given, okay, I will call it T data 1, T data dot drop. Then I will subset which index value. Let's say I want to drop index 1. So I'm taking this data, I'm dropping, and now I have to define that row number. So you see, 1 is gone. So we've seen an example of how to drop a column and how to drop a row. Okay. Back to our movies database. Okay. What was that? Okay, so we want to remove these unwanted columns. So this is all part of data cleaning. So we did this last time. Is somebody going to tell me how should we do this? What should I do else? Okay, at least tell me what will new calls variable return? What will this return?
Everything except unnamed.
Yes, so I've got sanitized list of columns. So I'm going to subset my data. Now we don't have those unnamed columns. Now let's check for some NaN values. So is null, right? That's a syntax. Null dot values dot any. Do we have any null values? Obviously, we must be having, of course. So, okay, let's get number of null values by columns. Movies dot is null. And let's take a sum along each and every column. So it's giving me a sum number of null values total by each and every column. So for all the column names, we have these null values. Okay. You see this? How our number of columns has shrunk so dramatically? So we had a lot of junk columns. Okay. Now, usually what happens is while you see a lot of numbers within a column in a real data set, but not all the data sets which come your way. In fact, most of the data sets which come your way, they are not clean. So you might have a number 845, but it may not be an integer. What does it mean? What should I get here? We have studied data types. It's very important to know what should I get here. What is the type of
Float. It could. Or
Int.
yes.
Sorry,
Int.
this is int.
Yeah.
How is this int? Then why have I put colons here?
Oh, then this is a string.
String.
Yes.
Yeah.
Do not get misled simply because you're seeing integer values here. And in the data, you won't even see integer value. You won't even see the quotes. But that data has been entered as strings. Those data is string. So now we're going to check. Okay. We are interested in, so which are the columns which will have numerical values, budget, revenue. So let's check whether they're actually string or they're numeric. Because if they are not numeric, we won't be able to do any kind of manipulation that we want to do or any kind of analytics which we're interested in running. So I'm going to do str dot, I want to check is numeric. Okay, again, we have a lot of nans. Our data seems to be full of these nans. So let's check. It's showing a lot towards the end. Let me check. We will do, okay, budget. Let's just check the tail. Tail will give us the last 5 values. But this is showing all zeros. Here is showing nans. Okay, that's funny. Okay, just check the data type. I'm going to pick any record here. Let's pick the very first record here and check what is its data type. These are all numbers. You see, this is a string, even though these are numbers here listed. So we need to first change this. Now what we are doing is beyond Python, we are doing data exploration and then we do data manipulation. So we need to replace the zeros because when we did a tail, we saw zeros, and at the same time convert the string data into integer. So we are doing two manipulations here. What are the two manipulations we are doing?
Regarding the budget and
No, but
the
what are the two operations which we are going to be performing here? I just wrote in the title. We want to replace the NaN values.
yeah, and replace it with
We are replacing it with 0 only. And I want to change the data type. So I'm saying as type int. That is the syntax. Now let's see whether this is sorted. Movies, budget, into 0. Oops, we're getting a value error. Invalid literal for int and base. Okay, so there is this value. There's some junk here, but the bottom line is we are getting a value error. Can we sanitize movies budget column? We are getting a value error. So what I want to do is this. Let us make I want to make a sanitized list of index values. That do not have value error. That do not have value error in the corresponding budget value. How can we do this? We want to avoid all the value errors. So I want all the clean index values. How can we do this? First, we need to iterate, right? We have to go over each and every record. You remember, try and accept. You remember or you don't?
yeah, I remember.
So I'm creating a temporary variable here called as int. And I will say make try converting this particular value, each and every value in budget. For each every index value, each and every index value, whatever is the corresponding budget value, convert it into an integer. And if it is getting converted, is appended to index, except value error, in which case just continue. Okay, so these are the sanitized indexes. Let's see if it works now. So I'm not going to fiddle with the original. I'm going to create a copy. I'll call it copy one, movies one. Always be careful, never do any experimentation. We are still in a trial and error mode. We are trying to clean the data. We are checking values in different columns. We are trying to clean up. We are trying to sanitize. Whenever we are doing this, let us not do the manipulation on our original data, because that will get manipulated and we will again have to then read it. So we should have a clean original data in its purest form, and let's do a manipulation on its copy. So I'm subsetting only the clean index values which do not have any associated value error. So, okay. If this is the case, then we can subset movies one. This is clear, right? I'm giving these index values, which are the clean ones. So what are we doing? We are filtering the data frame by selecting only the index values in variable indexes. Okay. Okay, if that is the case, then let's try that again. Okay, is somebody going to tell me what have we done so far? What have we done so far? Where did we start from? We were
First we
trying to
tried
convert the
replacing
budget values into integer and we got a value error.
yeah.
What have we done?
Then we wanted to remove those value errors. So we made a program where for I in the range, where by iLog we removed the value error, cleaned the data.
That's at a very high level.
Yeah.
Give me step by step exactly what have we done. So we want to remove all the index associated with value errors.
Yes.
So how did we go about doing this?
First we start by identifying the type.
Yeah, but tell me in a algorithmic language. You don't have to tell me the code, but algorithm explains the logic. So the code is in front of you. Explain what is the algorithmic logic here. What are we trying to do?
So we went through the length of the file movies.
What is the first step? First step is you need to create an empty container. You want to store the clean index values. You need to have a container, right? Otherwise you can iterate. But where are you going to store those clean values? So you need to create an empty container, which is called indexes here. It's a list, empty list. Okay, now carry on.
And then we went through the length of the file movies. And
which file are we going to? Are we iterating over any file?
no, the data of movies.
Which data? Okay, so we are doing what?
We are going over the length of, we are iterating over the length.
Okay,
of the data movies.
and then
And then we try to take out the value error. We try to put the clean data in the index file.
now you're telling me the output. Give me the steps. You need to know the steps to be able to write the code.
We go to the column budget.
Okay.
In the budget, through ilog,
What are we trying to do once we are in the column budget? Now, what are we going to do?
we want to remove the string.
So, okay. You want to remove the string.
Yeah, the string data.
But what? So how are you going to do that?
By iterating over.
So you're already in budget column. Okay. So instead of, I can say budget and it will be the same thing. Because length of budget and length of movie is the same. So you're already in the budget column. What will you do at every step?
Identify if it is a string.
Identify what?
If it is a string or a number.
What are you trying to evaluate? What is a string or not? The budget column?
Yes, the column.
Which we tried to do earlier itself. We tried to evaluate the budget column here, tried to convert it into integer, the whole column. And it did not work, it gave us value error. So budget column definitely has a lot of value errors. And we want to remove them. So how are we going to remove?
First step would be to identify the errors, right? Which values are the errors?
Depanita goes step by step. You remember in one of the lectures, I told you about the algorithm. First, write down the algorithm. Then you write the code.
Yeah.
The logic is clear in your head. You're a human. The logic is clear in your head. The machine needs to be told like it's a baby, like a child. This is step 1. This is step 2. This is step 3. Right? You're telling because you're able to process in your head, okay, this is what I'm going to do, and this will give me the result. In machine language, tell me every step. So you want to clean the budget column and remove all the values which give a value error. So you want to cull out the numbers of indexes or index values which are clean. For that, you are iterating over the budget column, right? Now continue from here. So now you're in the budget column. Now what will you do?
Identify the integer value and put it in indexes.
How will you do that? You know, you're missing something very, very basic. What is the next step? How are you going to write a code? You are iterating over a budget column. So what is the thing which comes logically the next? You will go each element by element, right?
Yes. Yeah.
So you have to first go to element number 1, which will be identified by ilog I. Right? You're going each and every row wise. What is the value associated in that particular row, which is denoted by I in movies budget column? And you'll try to convert it into an integer. If it is getting converted, you are appending it to your container indexes. If it is showing a value error, except value error, then you're saying continue to the next row number. That is what is happening.
Yeah.
Yeah.
Was it so difficult?
Not really.
So, you know, you need to be very, very specific, very clear, very precise. And that will come with practice. And it's always logical algorithm. If I'm iterating over a column, the next step will be, I will go through each and every element one by one. So I've iterated over the column. Okay, fine. Now what has happened? What has happened as a result of this?
All the integer elements have been appended to indexes.
Integer elements have been appended.
The value errors have been removed.
Value error. So what is getting, okay, what is indexes, the container indexes containing?
It's containing all the int values under the column budget.
Incorrect. What is it appending? It is appending I. What is I?
Every element of that column.
No, incorrect. I is in range. So it will take values of 0, 1, 2, 3 up till the total length of this data. So how is it picking up the element? It would be picking up an element if I was appending movies budget.iloc I.
Okay.
So what is I once again, right? What is it that I is appending here? What is it giving us in indexes? It is giving us the clean index values.
Values, yes.
Which do not have any value error. Then what do we do next with that?
Then we make a copy of the original data so that the original data remains clean.
All
and
right,
we can,
fine. And
then we are indexing it. Yeah. You're printing the new data.
no, but then what are we doing? Okay, now we have clean index values. So what do we do with that clean index values? We subset the data so that it only contains the indexes which were clean, which did not have any corresponding value error in the column budget.
Yes.
That's how you get this. Now, if that really worked, you need to test it, right? So we should come back to the original thing that we were trying to convert the data type of budget column, correct? It did not work. That's how we went through this whole rigmarole of trying to eliminate the index associated with value errors, right? So if that is sorted, then it should work now, or should it not? So we remember that this is where we got the error. Yes or no?
Yes.
So if this is a sanitized data without any value errors in budget, then it should work now. Why are we still getting it? Just a sec. Okay. Okay. Okay, this should not be happening. Why are we still getting it as string? Okay. I still took the original data. Is it clear now? Did you understand this?
Yeah.
Yeah.
What happened? What was the mistake I did? I was checking the type of from the original unmanipulated data version, which was movies. Whereas we did all the manipulation and we stored it under movies one. So this is clean now. Okay. Now another numeric column here, feature here is revenue. So let us also try the same. Data type of revenue. So I will do movies one. Be very careful of these kind of errors, right? If I just do movies here and I'm not even able to detect that I'm taking the wronger version, then I'll just be clueless as to where the error was. I'm going to fill the NA values proactively. I'm doing. If it works, great. If it doesn't, we'll have to manipulate this as well. Let's check. Let's take any value. Okay, so this is clean. This is already converted to integers. Okay, then let's use a function called np where so why were we doing all of this? We wanted to find blockbusters, right?
Yeah.
So what should we define threshold for budget and revenue? So here we are saying that, at least it should break even. So we'll keep budget and revenue as equal. So what should be the threshold? It's Hollywood, so let's keep 100 million. You want movies which had a budget of 100, big movies, and which did at least a minimum 100. They recovered the cost. So NP where is going to help us cull out those index values. So I'm doing NP where, and it's very logical. Just watch. I'm putting the conditions where movies one budget was greater than 100 million, 100, then 6 zeros. So this is my condition one. Let me put it in a bracket. Okay. And we remember and or operators?
Yes.
Okay. So what should IND give me? IND will give me index values. Clear, right? So these are the index values associated with budgets greater than 100 million and revenues also greater than 100 million. So what should we do next? What should we do next? Subset, right? It was clear?
Yeah.
So let's see. You see, all the budget values are greater than 100 million. But this still has too many columns. So let us try to just subset. And okay, we need one more thing. Let's look at what production companies do we have. Let us explore column. Oops. Okay, this is quite a mess. We need to be able to okay. Let's make it a little elegant by replacing. First, let's look at what is the data type of this. So I'm going to take this is what a record looks like. So let's take what is the type of this record. So we can actually see what type of record it is. Does anybody want to tell me what kind of a record this might be?
Would be a string
Why?
because it's the name of companies.
No, that's not the reason. It could be a list object also. It's enclosed within square brackets. What is it?
It's into inverted.
Yes, yes. That was a giveaway. It was in quotation. It's a string object. And it has a lot of things going on inside. Right? All we are interested in are the names of the production companies. So I want to first iterate over this column. Okay. Now, let me remove the type so that we can see what does our data in each of the row looks like. What does each of the records? So it looks like this. We want only the, so if this is a string object, you remember we studied when we were doing list that we can split a string. Sorry, when we were studying string, you remember that we can split a string? Please keep revising. Okay. Let's just do a trial for up to 2 values. Now, this is a string. I want to split. Let's see what we get. Print item and also the type. So this is the item. You see how you're seeing what is happening here? It has broken up into individual items. And its type is list. So when we are splitting a string, it is breaking up those individual items and putting them into a list object. So this becomes a list data type. Now, if it is a list data type, so I can iterate over this.
Yes.
Yeah.
Okay. So I'm putting a container called PC production companies. I only am interested in the names of production companies. So I will say for J in the range of length of item, correct?
Correct.
Item is a list.
Correct.
If, watch this carefully, what will we say? We are seeing that production company names are coming after name. It's a dictionary here. Inside name, key, production companies. And for one movie, there are multiple production companies. Notice this. This is one record. It has Ingenious Film Partners. It has 20th Century Fox. Then it will have Dune Entertainment. It also has Lightstorm Entertainment. You have multiple production companies associated with one movie. And they are all appearing after name. Name is the keyword. So I say if name in item J, correct?
Yeah. Continue.
Yeah.
No.
Append. Yes. Append.
What will I append?
Item.
Value.
Yes.
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 But not just the next value. If I append the next value against this, I will get only Ingenious. Let's at least append 2 values. So I'll get Ingenious Film. I'll get 20th Century. Right? I'll get Lightstorm Entertainment. Sorry, J plus 1 and J plus 2. The next 2. Correct? You understanding this logic of why am I using J plus 1 and J plus 2?
Yeah.
The next 2. So they are getting appended to PC. So this is for record I in production companies. So now what do I want to do? Movies 1. Production. Sorry. I want to replace the ith value with PC, right?
Yes.
I don't want this whole long record. I only want the names of production companies. Okay. If this is the case, okay, fine. Let me not do this. Before I modify this, let me print and see whether we are getting the right one. Yeah. So we are getting the records like this. So now I will do for the whole data. So you see the value of print statements. If I was making an error and I was directly modifying movies one, then I would have had to go back and create movies one record all over again. Okay. So if that is the case, let's check then movies one production companies. This is better, right? Against each film, you can see a list of who were the production companies. Clear so far?
So what was the error earlier? Why
There
was
was
it?
there was no error. The
Okay.
record was like this.
Okay.
So out of you have ID number, you have name, right? We were only interested in the names of production companies. So out of this whole string, we have now created, or now we have created what? We have created a list object which contains the names of multiple production companies associated with a movie. Like this.
Okay.
You see the difference?
Yeah.
Or you don't?
Yes. Understood.
Yeah, I understand.
Now
this.
there are too many columns here to deal with. Let us filter it down to the columns which we are interested in. So I will say we want budget, we want revenue, we want genres, and let's say production companies. Okay. Column of interest. So I want to show that we are subsetting here. So I want to show these columns. Okay, and one more thing, and we want movie title. So you want these columns where what was the condition? Where budget and revenue are greater than 100 million USD. Okay, so let's call them hits. Okay, so hits which had a budget and a revenue greater than $100 million. Okay, so fine, let us subset movies one by these columns: budget, revenue, genres, then original title, name of the movie, and production companies. Correct? So we are performing two operations here. What is the first and what is the second operation? Please tell me. It's in the title, but please explain it to me. What are we trying to do here? What is end? We created a variable end. What is end? It is subsetting those records where our conditions are met, where budget and revenue is greater than $100 million. So I want those records where my budget and revenue were greater than $100 million, but I want the data frame to be subsetted to only these columns. Now clear?
Yeah.
Okay. So hits 100 genres. Let's see what were the genres which created these hits. So these are the main genres, but there are a lot of records here. So tell me what else should we do? And think of what else you may want to do. So now we have a list of movies which did over 100 million in revenue, and they had a budget of corresponding budget of 100 million as well. Right? So let's call these big movies. Now you want to know, if these are all blockbusters, assuming, don't you want to know that, which genre did how much of business, or how many of these hit movies belong to which genre?
Yeah.
Keep coming up with ideas as to what you want to do with it, with this data. So the problem definition is entirely in our hands. So let us filter how many movies within hits 100 belong to, let's say, 3 important genres. So let's call it animation, comedy, and sorry, what is this? And we are seeing action. So let's say action. So let's see how many of movies belong to this. So once again, for I in range, now how will we check this?
If anim is
Yes, in
hits 100,
yeah. Then which column?
column
Genre.
Yes, right. And within genres, a specific record.
I log I, yes.
Yes. Then what should I do?
Append. We need to append it to animation.
What should I append? I? No. You want to append the value.
Okay. Then genres, yes.
So similarly, if comedy, sorry. Okay. And likewise for action. Okay. Now we will say print number of animation blockbusters. What should this be? Length of animation? Correct?
Yes.
Yeah.
This backslash is to go to the next line. And I will give you guys the reference to this data on Kaggle. There are many such data if you want to practice. Okay, let's see. What is invalid? Animation.append. Okay, what is the mistake?
Colon. Yeah, colon is there. Okay.
Action.append again. Why am I getting a dot here? So action seems to be ruling. Okay. If action is ruling, okay.
Which is the highest grosser action movie?
Sorry?
Which is the highest grosser action movie? Can we take that out?
Highest grosser action movie.
Yeah.
Okay. Okay. Let's first, take one more function. There's something called group by. I want you guys to know this. So what this is going to do is something interesting. It's going to let us group them by genres, and we can say find average budget and revenue. So it's very simple. What we are trying to do here is we are taking all the movies in Hits 100. I'm going to group them by genres within square bracket column, and I want to find mean. So it will give me by genre what is the average budget. Okay, what is the mistake now? I've made okay. So what is it telling me? By genres, what was the average budget and what was the average revenue? But it's very difficult to read. Can you tell what is the revenue or even the budget? So let's modify this. Okay, is somebody going to tell me how we can modify this? I just want to convert the budget and revenue into, let's say, million values. Or we can say billion, whatever, million. So I will select those columns. We remember the apply and map functions. So I want to apply a function here which will convert these values to millions in one single line of code. Lambda, what should it be?
X oblique, yes.
Okay. Now it's more readable. So now let's look at those. Group by again. So column name, I need to put it in square brackets. Okay, so what does it tell us? If you're a producer, what does it tell you?
That action movies generate the
Yes, yes, put your money in action. So how many movies were there? We know the shape of an umpire array. Pretty much the same. So this tells you that there are 264 movies in our record. And the size will tell you the total number of elements. And this is intuitive, right? The total number of elements is going to be the total records into columns, the rows into columns. Okay. This is again something very neat. Aggregate. Gives you a nice summary. So again, let's take this one. Budget, revenue. We need one more square bracket. Okay. And I want to aggregate and find mean, minimum, let's say the maximum. For budget and revenue. For these two columns, I want to find what is the mean value, what is the maximum across the entire column. Okay. Okay, let us do aggregation individually. Using, so these are all functions, right? Mean, minimum, max. Here we've used a common function for both the columns. Now let's try different functions for different columns. So what I'm really interested in finding is that what was the total money which was put in by these hit movies? What is the total budget which went in, and what is the total revenue produced? So at a summary level, I can see the minimum on an average that in this 100 million blockbusters, the average budget was 155 million and it gave more than 3 times the return, 508. But I want to know at a consolidated level. So let's aggregate this. So I will say movie one. First, the value will be, because we're taking a consolidated, the values can be very, very large. So let's convert this time into billions. Okay. Do apply first.
Lambda.
That's converted into billions. And this time we are not just limiting ourselves to hits, right? We are looking at the whole database. That's why we're taking movies one. So convert budget and revenue into billions. All right. So I will run this. Now let us aggregate. Movies one. Okay, movies one. Let's just go to aggregate. Or I will. So I will say, let's say budget. Value. And I will say function will be sum. Okay, next I will take my revenue. So the industry put in our records, the filtered record, the industry put in $139 billion and they got $395 billion in return revenue. Over what period of time, we do not know. But now you know that movies is a good business, right? And if you did not know pandas, you wouldn't have known this, right? You agree?
Yeah.
So what's
Yes.
better? Python is better or movies?
Movies with Python.
Yes. So you should know data science. Data science will help you discover where is the pot of gold. So on that note, we will end and we will see tomorrow.
Thank you.
Was it good today?
Yes.
All righty. Bye-bye.
Bye.
Thank you.